Hi everybody, today we're going to look at average rate of change and a bit about Leibniz notation. Leibniz being one of the two founders of the whole calculus idea, Newton being the other one. So, given first principles, the gradient at a point, and I'm missing a bracket there, so let me add it in, equals the limit as h tends to 0 of f of x plus h take f of x on h, where h is a very small change in x. Now, we can rewrite this by denoting the small change in x as delta x, and this symbol over here is lowercase delta, and typically we talk about delta x being a very small change in x, and the change in y is delta y. Now that allows us to rewrite this part as delta y and this part as delta x, and then we can write the gradient formula px f of x is equal to the limit as delta x approaches 0, as this becomes very small, the change in y divided by the change in x. And we commonly write this whole thing here with the limit as dy on dx, and we say it dy by dx, and we don't bother writing the limit anymore because we know what this means. This means the instantaneous rate of change. Now, there's other notations. There's f prime x, which should also be the first derivative, and there's y prime, or sometimes y prime x, which is also the first derivative. But the most common one is dy dx, because I reckon it looks nifty and mathematicians are a little bit snobby about it. I actually find that these two most of the time are easier to work with, unless you're doing chain rule. Anyway, let's keep going. We're not going to look at the instantaneous rate of change, or the change at a point now. We're going to go back to looking at the average rate of change, just for a little while to make sure that we have that idea well and truly nutted in. So here we are again with that graph you saw before. Here's the difference in x values between 2 points on the curve. Here are the corresponding y values. And we know that this height divided by this horizontal distance will give us the average rate of change from B to A. So after 1 unit, it would be about halfway up this red line, and after 2 units, it would be all the way up to A, if we had, in this case, 2 units between x and x plus h. So it's the average rate of change. Now we know that it's not the actual rate of change because we've got a curve, and at this point it's changing less, and at this point it's changing more. So after 1 unit, we would expect on the curve to be not as far as on the line in this example. So here we go. After about 1 unit, if that was the average rate of change, our curve would end about here, about twice this distance, up there, about there. But we can see that the curve increases its rate of change, so to there and then to here, but the curve increases its rate of change as x increases, so that rather than finishing about here as it would for a linear equation, it goes all the way up to here. But the average rate of change still gives us a good idea about what's going on. So if we're wanting to find the average rate of change given an equation and 2 points, we might be given a situation like this. Given y equals 2x squared, find the average rate of change from x equals 2 to x equals 4. Substitute 4 into the equation and we get 32. Substitute 2 into the equation and we get 8. These are our two y values. We already have the two x values. So the change in y divided by the change of x would give us the gradient, or the average rate of change. So it wouldn't give us, will it? Yeah, it'll give us the gradient of the line, but it also tells us the average rate of change. How far would y change if x changed by a unit? So at this point, it would be 32 take 8 divided by 4 take 2, which would give us 13. So we'd expect this after 1 unit to move about 13, and then on the second one to move 26. So let's check if that's correct. 8 plus 26 is 32. Yeah, with 13 each time. So there you go. A little bit about notation and a little bit about average rate of change. So if we put the concepts we've done together so far, we've learnt about the limiting chord method, how to find the tangent at a point, the gradient of a chord, and now a little bit about Leibniz notation. And the next steps are now to look at differentiation properly and go from this unwieldy first principles to something that's a little bit easier to work with. Thank you, everyone. I hope that was helpful.